All right, our video tonight should be pretty short. We only have one type of problem to cover, so I'm just going to do two different examples of that kind so that you feel pretty confident about this when you come into class tomorrow. All right, just a quick reminder about quadratic versus linear. So quadratic is anything that has x squared in it. It looks like a U shape, which we call a parabola. Linear only has like an x or a y in it. So an example of linear would be like y equals mx plus b, right? And linear, like it tells you, is going to have a straight line. Forms of quadratics, now this is important, and this is really what we're going to focus on today, is talking about what does each form give us. So if you remember, from this first form is called standard form. And this is the same problem. Today we're going to talk about kind of how to go between the two different forms, or at least one direction. Standard form, I can see automatically that this opens down, and I have a slope, so to speak. And then remember the last number that's by itself is the y-intercept. So I can see that this is going to hit the y-axis at negative 17. In vertex form, which is the one that we spent more time on today, that's the one that we do like the left, right, up, down. We can still see that this is down and it has a slope of negative 2. Remember, we can only do that because this is a whole number. And then we can also see I've got right 3 because it's opposite, up 1. And remember, this gives us some other information. It tells us the vertex is going to be at 3, 1. And from the vertex, we can actually figure out the axis of symmetry. Remember, we use the x part is x equals 3. We know domain is always all real numbers. And we can even figure out the range from this form. Remember, the range is from the y. And because this one's opening down, it's going to be y is less than or equal to 1. And remember, I'm getting that value from the y part of my vertex. So standard form doesn't really look like it gives us a whole lot. It just gives us the y-intercept, while vertex gives us all this other information. There is one more form that we're going to learn about, and it will give us two more pieces of information that we still haven't talked about so far with quadratics. I've shown you, but we just haven't seen it on the graph. Okay, so here's our first example. What they're going to ask for us to do, or what I'm going to ask for you to do rather, is I am going to ask you to rewrite it in standard form. So I'm going to show you how to do that. But really the goal, more than anything, is to get as many of these pieces of information as we can. Okay, so if I want to find the vertex, I can actually already do that. Remember, the vertex comes from these two pieces. So it's opposite. So this is right 6. And then this one's the same, so up 3, which means my vertex is going to be at positive 6, 3. From that, I can find my axis of symmetry, and that is going to be the x value, x equals 6. Domain is always all real numbers. Range, if I look here, my graph is opening, that's a positive 4, so my graph is opening up. So my range is going to be y greater than or equal to 3. The parts that I can't see so far are my y-intercept and my roots. So we want to talk about how to rewrite this. And the first thing that you may see, if you think about order of operations, right? I've got please excuse my dear Aunt Sally or PEMDAS. I have to do the exponents before I can do any multiplication or distributive property. So the first thing I'm going to do is 4 x minus 6 x minus 6 plus 3. Notice that I'm writing that out twice because of the exponent squared. It's important that you know that. All right, now I'm going to multiply these things together before I deal with that 4. So when you have this, remember that we're going to distribute twice. So I'll color code it for us. So I've got 4, and then this is going to be one big long parenthesis. x times x is x squared. X times negative 6 is negative 6x. All right, now I'm going to distribute with my other negative 6. Negative 6x plus 36. And then I've got my plus 3 at the end. So if you need to rewatch that part, you need to know where all of those numbers are coming from. Okay, and now I'll go ahead and distribute. I think I've found in the past that people like to distribute and then combine everything at the end. So now the only thing I have left to distribute is this 4, which is going to give me y equals, let's see, 4x squared minus 24x minus 24x plus 144. And then I still have my plus 3 here at the end. All right, so notice kind of what I'm color coding for you. All right, and now we're just going to combine our like terms. So I'm just looking for anything that I can put together to make this any simpler. So I've got two terms that have x's, and these both are just numbers at the end. So if I'm rewriting in standard form, my last statement is y equals 4x squared minus 48x. I'm adding those together. Remember, when you add, the exponents don't change, plus 147. All right, there's my standard form. And then that will help us answer my last question of what's my y-intercept, which should be 147. Remember, it's the number that's by itself. The roots, that's the part that we haven't talked about yet. But if you don't know how to, that seems like a lot of work to do just for y-intercept. But if you don't know how to get it into standard form, then we aren't going to be able to do the next part, which is to find the roots. And that's almost one of the most important parts with quadratics. All right, if you will copy this problem down and just have it ready to go for your notes tomorrow, we can start here. If you feel confident and you want to try to go ahead and fill in the pieces of information that you know, you can go ahead and do that. And then we'll work on this one tomorrow just so you feel a little bit better before you start into your homework.